This question is from GATE Mechanical Engineering of 2014. This is question number 2 of set 1. The question is, limit x tends to 0, x minus sin x upon 1 minus cos x, and we need to find the value of this limit. So let's write down the limit here. Limit x tends to 0, x minus sin x upon 1 minus cos x. Now if we substitute the value of x in this given limit, so we'll get 0 upon 0. Okay, that is a indeterminate form, right? Now these indeterminate forms can be solved using L'Hopital's rule. So let's see what L'Hopital's rule is. L'Hopital's rule. Okay, so according to L'Hopital's rule, if we have some function, suppose limit x tends to a, f of x upon g of x, and this f of x upon g of x is an indeterminate form. Okay, so this one is indeterminate. Okay, so if this is indeterminate, let's say 0 by 0 or infinity by infinity, so this limit can also be written as limit x tends to a, the first derivative of this function f dash of x upon g dash of x. Simultaneously we can differentiate the numerator and the denominator with respect to x. Okay, and suppose this again f dash of x upon g dash of x is indeterminate, so again we can differentiate it. So this will be limit x tends to a, f double dash of x upon g double dash of x. Okay, now for this problem what we can do, we'll write limit x tends to 0, x minus sin x upon 1 minus cos x. So this is indeterminate form, so we can write using L'Hopital's rule, limit x tends to 0. Now we'll differentiate the numerator, so let's write it here, d upon dx of x minus sin x upon d upon dx of 1 minus cos x. So this will become limit x tends to 0, this is 1 minus cos x upon 0 minus, and this will become plus because the differentiation of cos x is negative sin x, so this will be positive sin x. Now again we see that this is indeterminate form, right? Because if we substitute the value of x is equal to 0, so this will be 1 minus 1 0, the numerator is 0 and the denominator is also 0. So again we can use L'Hopital's rule and we can write limit x tends to 0. We'll differentiate the numerator with respect to x, so this will be 1 minus cos x upon d upon dx of sin x. So this will become limit x tends to 0, so the derivative of cos x is negative sin x, so this will be positive sin x upon this will be cos x. Okay, or we can also write this as limit x tends to 0, sin x upon cos x is tan x, and we know that the value of tan 0 is 0. Okay, therefore option A is the correct choice. For more information you can refer to the NPTEL course lecture number 24, L'Hopital's rule on basic calculus 1 by Professor Arindam Singh from the Department of Mathematics at IIT Madras.